next math unit that we're going to be working on is called geometry. Geometry is the study of shapes. You have been learning about shapes and geometry since you were in kindergarten, and probably even before then.
I'm good at geometry.
Thank you. When mathematicians think about shapes, one thing that they really focus on are what's called an attribute or a rule to that shape. So I'm going to be giving you some different shapes that we're going to be cutting out, and then we're going to sort them into piles by what makes them similar versus not similar. They are numbered. You are not going to get them in order. We're just going to go page at a time. The first page that I'm going to give you has 5 shapes on it. You do not need to cut the shape exactly. Just a quick rough cut around it is fine. Does that make sense? Yeah. Because we've got a lot of shapes to cut out today, that if you spent time actually cutting all the shapes, it would take you forever. So just a little rough cut. Does that make sense? Yeah. Once you've got them cut out, I want you to sort them by what is similar with the shapes that you've got. Okay? All right. All right, let's talk about how did you sort your shapes? What were the rules that you used to sort your shapes? Lydia, what rules did you use?
So I used how many sides and corners each one had.
Okay, so how many piles did you have?
2.
Okay, Lydia had 2 piles. What was the rule for one of your piles? What did it have to have?
4 sides and 4 corners.
Okay, so Lydia had a rule that said they had to have 4 sides and 4 corners. Did anyone else have that rule? Lydia, what number shape went in this category?
Like how many?
No, what number written on that shape?
24.
24. 24 kind of looks like, yeah, kind of look like this. Would that make sense? Would that be a 4 sides, 4 corners?
Yes.
Yeah. What else would go in that category? If you made that your category, what other number shape would go in there? Marlon? 23. 23 kind of looks like this diamond-y shape. So, Lydia, if that was your category on this side, what about your category on this side?
It would be no sides or no corners.
No sides, no corners. What shape went in there? What number shape do you think went in there, Callie?
Circle.
What number is it?
Oh, 25.
25. We're going to stay away from naming shapes, only because the reason we name a shape a certain shape is because of these rules. So we're going to call them by the numbers. Connor, what's up?
What I guess there's on my pile is that I put the squares in one pile so you would know that they have 4. And I put some of them that can be made out of 2 shapes. How's it going to be? And there's going to be 2 squares.
Can a square be 2 shapes?
No, it could be, yeah.
So let's think through that rule. What makes it one of those piles different from the other?
The one with the square is that it has.
So Connor's saying that he made a 3rd category, but he's having trouble naming them. He put a shape like this in that category. What rule would that category be? It can't be 4 sides, 4 corners because then it would just go in this one. Yeah, but what's that rule? How do you know it's a square? Because why is that not a square? Not a square. Not a square. These are where there's rules come in handy. Jordan?
4 4 equal sides? Like 4 equal size sides?
Okay, so Jordan thinks maybe if you wanted to make 3 piles, go ahead and make 3 piles. One of them just has 4 sides, 4 corners. But then there are some special ones that have 4 equal size sides. There should only be one shape in there with 4 equal size sides. What number shape has 4 equal size sides? Cole?
22.
22. 22 should be in its own pile. 23 does not have equal size sides, does it?
Yeah.
Oh, so let's move 23.
Okay, 23 and 22.
Who's 22? Oh yeah, 22 is the one that we already moved. Ooh. Depending on our rules, we might have to move some shapes. I love that. I'm going to give you another set of shapes to cut out. You tell me, where does that one go? When you get your new shapes, you might have to make new piles, depending on what your rules are. So we had a pile that was just 4 sides, 4 corners. Then we had a pile, no sides, no corners. And then we got that special pile of, it has 4 sides, but they are equal sides. What were some new piles? Or did you add to any piles? Archer, you had some new piles, or did you add to a pile?
I made a 3 side, 3 corners.
Okay, so Archer made another pile that said 3 sides and 3 corners. Give me 2 signal if you also came up with something like that. You also came up with a pile that said 3 sides, 3 corners. All right. What number shape went in that pile? What number? What number, Lydia?
17.
Can you hold it up so I can see it? 17.
And
Definitely would go in that pile.
I also made another pile.
Hang on to that. Ava, what else could go in this pile?
19.
19. Hold it up so I can see it. All right. That looks like it has 3 sides, 3 corners. Marley? 20. Hold it up so I can see it. Some of you, I see another pile on your desk. What other pile did you make? Some of you have even more shapes, more piles. Addison?
I made a pile that is like 4 3 non-equal sides.
Okay, so
Sides aren't equal.
so we had 3 equal size one.
No, like not equal.
Yep, which means you also had an equal one. Because if you had a non-equal one, that means the other one's equal. 3 equal sides. Does one of ours need to move?
Oh, yeah.
Yeah, I think this one right here, right?
Yep.
So we had a triangle that looked like this. What else went in that category that had 3 equal shaped sides? Samaya, what number? 16? Hold it up so I can see it. You want 16? Yep, we got 19. Any other pieces in this new category? It's not a trick question, you just gotta look at the pieces. Emma? Tricky. There might not be any others, I don't know.
Yeah, the same thing.
There's
Yeah,
not.
all we have is 17, 16, 20, and 19.
Yeah, I think it's just 19 in that lemon category. All
Oh.
the others have different size pieces. So now we've got 5 different categories.
Yes. Yeah.
Shapes with 4 sides, 4 corners. Shapes with no sides, no corners. Shapes with 4 equal sides. Shapes with 3 sides, 3 corners. Shapes with 3 equal sides. Lydia?
I was wondering if we could do one like 2 equal sides,
What do you mean by that?
like 2 sides that are like the same length.
4 triangles?
Yes.
Sure. Lydia said, I wonder if we could do 2 sides that are the same length. In a triangle, if you have 2 sides that are the same length, you have all sides that are the same length. It's hard to tell with those pictures. But if you have 2 of the sides that are the same, they all end up being the same. It's like a weird triangle quirk. Alright, I'm going to give you another set of shapes. See if you can sort this next set of shapes.
I had an awesome.
Where did some of these shapes go? We ended up, or we started with 1, 2, 3, 4, 5 categories. Where did some of these shapes go? Or did you make a new category? I don't know. Where did they go? Paxton, I see you sorting shapes over there. What are you sorting them into? What rule are you using? Paxton said he put all of these shapes into 4 sides, 4 corners. Is that where they go?
Yeah.
All right, let's pick up number 11. Number 11 looks like this. Does this shape have 3 equal sides?
No, it has
No.
4 equal.
Does it have 3 sides?
Yeah.
No. Doesn't even have 3 sides. We need to be in one of these 4 sides. Does it have 4 equal sides?
No.
4 sides, 4 corners?
Yeah.
Yeah, it should go in the 4 sides, 4 corners. Make sure that number 11 is in the 4 sides, 4 corners. It looks like this.
Where's 11?
Now some of you are noticing it looks different than the ones that are already in 4 sides, 4 corners. What looks different about them? You don't have your sorter. What looks different about the ones we just put in 4 sides, 4 corners than the ones that we had in there? Because we had shapes that look like this, and now we have shapes that look like this. What's different about them? Avery?
What's different is, wonder, so it has, it kind of, all of them go in, all of them go, I don't, put them on, it kind of, it's more, I don't know.
Why do they look different? You know they look different. You can tell. They kind of look a little bit different than the ones we had there. Why? What's different about them? Maxon? Bowen, no thank you. Marlon, what are you thinking?
They all have the same size. Like, so circle has no size.
Okay, but we're not in the no sides, no corners category. We're only looking at the 4 sides, 4 corners. And the shapes we just put in there look a little different.
They're not.
Well, neither are the ones that were in 4 sides, 4 corners. Right? This one doesn't have 4 equal sides. Does this shape have 4 equal sides?
No. Yeah.
No. That side is way smaller than this other side. Archer, why do those look so different?
The pieces before we put the these are more square
Okay.
and these are like ziggy.
By number 14. Find number 14. Put it in front of you. Find number 14. Put it in front of you. Number 14 looks real pointy. Does that mean it goes with the other pointy things, like my triangles?
No.
Are you sure? It looks really pointy.
No. Just because it looks pointy doesn't mean.
Where does this shape go? Raise your hand and tell me. Oh, it's pointy. All right, thank you. Julian, where's the shape go?
For equal size?
Are all of these sides the same length?
No.
No, so it's not going to go in 4 equal sides.
4 sides, 4 corners.
Yeah, this shape, even though it looks kind of crazy, like this. Oh, that was not a good drawing. Still not a very good drawing. One more try. There, that's a little better. Even though it looks kind of pointy, like a triangle, a rule of a triangle is that it has 3 sides. This does not have 3 sides. It has 4 sides, 4 corners. We're going to do one more additional sort. So one more set of shapes to cut out. Jordan, what's up, friend?
There are also like trapezoid.
What does that mean?
It means like it looks like they're like slanted sides,
This one has slanted sides.
but like the 2 slanted sides are equal and there are 2 like long sides.
Always.
So kind of like the diamond.
So the reason I'm not naming them yet, Jordan, is we don't have all the rules yet. The way that you name a shape is not by, well, it looks like this. This looks like a triangle. Got that real pointy side. Looks kind of like a triangle. But we know this is not a triangle because it doesn't follow the rules. We're not going to name a shape until we know all the rules. Does that make sense? Okay. I'm going to give you one last set of shapes to cut and sort. When you get them, add them to your piles, please. Starting some of these shapes go in a category that we already have. Can you find a shape that you just cut out that does go in a category that we already have? Which one of these shapes goes in a category that we already have? Maxim? A 4 sides, 4 corners. Which number shape? 2. Find number 2. Find shape number 2. Find shape number 2. Now, number 2, Paxton, looks like a triangle to me.
It's not a triangle.
Looks like a triangle. It's very pointy like a triangle. It's got that nice top point. Paxton, is this going to go where I think all those other triangles go?
No.
Where does this go? Ooh, Paxton count the sides. 1, 2, 3, 4. And in the corners, 1, 2, 3, 4. Even though the shape looks triangle-ish, does it go with the triangles? No, we've got to use our rules. This has 4 sides, 4 corners. It should go in this pile.
The reason it's in the fours is because the bottom point. The bottom point.
Yeah, it's got 4 sides, 4 corners, even though it doesn't kind of look like it. Now, I think we got to make some new categories.
Yes.
What are some new categories that you had to make? Because I think we had to make some new categories. Addison, what was the new category that you made?
The new category I made was 6 sides.
6 sides? What were some shape numbers that went in the 6th sides category. Go ahead, Addison.
It could be number 4.
Number 4. Let me look at number 4. Let's see. 1, 2, 3, 4, 5, 6. Yeah, it kind of has this triangle shape-ish bottom. Looks kind of like that. Almost looks like a dinosaur fin. But Addison's correct. Even though that shape looks triangle-ish arc, it's got 6 sides. Addison, does it also have 6 corners? Yeah. Yeah. Were there any other new categories? We had a 6 sides, 6 corners. Were there any other new categories? Archer? Addison gave us a new category of 6 sides, 6 corners. Is there another new category? 5 sides, 5 corners? Give me 2 signal if you found shapes that had 5 sides and 5 corners. Nice. Avery, what was one shape that you found that had 5 sides and 5 corners? 6. Hold it up so I can see it. Oh yeah, kind of looks squarish. But is it a square?
No.
Doesn't follow the rules. We have to go back to those rules. Kind of has that squarish bottom, but then it looks kind of mountainy. Not squarish. Sorry, I took that from you. I'm not sure where it is. Emma?
So I have a new category, but it's from the shapes of triangles.
Okay.
So we have same size, same shape, but different.
Emma, let me ask you this question. When you get older and you grow, are you still Emma or are you a different person?
I'm still.
You're still you. So if I take a triangle and I make it bigger, is it a new shape?
No. Yeah.
No.
It
still has the same rules, so it still goes in the same category. Just like if I take this shape and now I hold it this way, is it a new shape?
No.
What about if I hold it this way?
No. Different perspective.
Different perspective. But if I pick up Jordan and I'm holding him upside down, is he now a new person?
No.
Yes. No, still a Jordan.
Upside down person.
Still a Jordan. Alright, this morning you've heard me use that word attribute a lot. I want to give you some other synonyms that you might see or hear when talking about attributes. We might hear words like rules. We use that word a lot today if I'm talking about the shape attributes. If I'm writing, you're writing. I'm talking about the rules. You might hear words like categories. When we were sorting today, we were sorting into different categories. We were sorting by attribute. The last word you might see or hear, we've used in other domains of math. Which is a property. When we talk about the commutative property, that's a rule. It's a rule in math. When we talk about break-apart property or distributive property, that's a rule. This is a new domain in math, but we still have properties. An attribute. Is a characteristic of a shape to determine what shape it is. It's a rule of a shape that helps us figure out, okay, if it has this stuff, then it must be this shape. A characteristic of a shape to determine or figure out what shape it is. One of our shapes you already know that we sorted was a circle. If I said, how did you know it was a circle, you would give me the rule. You would say, oh, because it had no corners and no sides. That's the rule, that's the attribute, that's the characteristic. That's what makes a circle a circle. Now circles are pretty easy because they pretty much only have one rule. But the shapes that we're talking about in 3rd grade are going to have more than one rule. They're going to have many attributes. No. Yes, if I'm writing, you're writing. No, I said you're not writing in red color, but yes, you are writing it. I thought you were asking me, do you write it in the color red? Like, get out a crayon. You did write it. It's the same thing that we just talked about. Shapes can have more than one attribute. And we started looking at that. We had a whole special group of triangles. That special group of triangles had 3 sides, 3 corners, and it had equal sides. There's 3 attributes right there. 3 rules. So in 3rd grade, the shapes that we're talking about are going to have more than one attribute. And you got to figure it out using all of those attributes. What shape is that? Go ahead and write that question. What are the rules of a triangle? What are the rules of a triangle? Are you writing it down? Julia, make sure you're writing on the lines, please. The attributes of a triangle you likely learned in 1st grade. In order for the shape to be a triangle, what's something that it has to have? What's something that it has to have? Avery?
It has to have 3 sides and 3 corners. They don't have to be equal though.
Oops. 3 sides, 3 corners. Are there any other rules?
Mine
3 sides, 3 corners. Ava?
they don't have to be equal.
They don't have to be equal. Is this a triangle?
No.
I've got 3 sides and 3 corners.
It's not equal. There.
They don't have to be equal.
I didn't see this.
Is that a triangle?
No.
No.
It's not.
So that means I need another rule. Because that does have 3 sides and 3 corners. That means I need another rule. Marley, turn around. Robert?
The 3 lines have the 3 equal sides have to be straight.
They don't have to be equal, but they do have to be straight. So that is not a triangle because it doesn't have the straight sides. All right, so I need 3 corners, 3 sides, and I have to be straight. Got it. See if I can make one. Is that a triangle?
No.
Yes.
No.
Yes.
No. Yes. No, it's not connected.
It's not connected. It's not triangle.
Not a triangle, not connected. We have a special name for this. We call it closed. That shape is not closed. It's got an opening. So it must be a closed, aka connected shape. You don't have to write my non-examples if you don't want to, that's fine. But you do need the rules. So right there, our triangle has 3 rules. It has to have 3 sides, 3 corners. We figured out that that wiggly triangle shape-ish was not a triangle because it didn't have straight sides. And then that last one wasn't a triangle because it wasn't closed. So in order to be a triangle, it has to have those 3 things. Now, we learned that could it also have equal sides? Could it also have equal sides?
Yes.
Yeah, it could. But is that a requirement to be a triangle? No.
No.
You could have unequal sides and still be a triangle. I see a lot of playing in desks. Please stop messing with whatever's in your desk. Turn to the next blank page. Write this question. What are the rules of a quadrilateral? If you don't know what that is, that's all right. We're going to talk about it. What are the rules of a quadrilateral? In 3rd grade, we are going to talk a lot about quadrilaterals. There's many different categories of quadrilaterals. Quadrilateral has a prefix, just like triangle, that gives us a good hint. I want you to underline the chunk that says quad. 4. That prefix quad, go in.
Quad in Latin means 4.
Quad means 4. You have a quadriceps. It's in your legs, right here. Guess how many parts are in a quadriceps? Video? 4. The rest of this lateral
Shape.
sides. So what rule do you think is a rule for a quadrilateral? It's not a trick question. Marley, what do you think?
means 3.
Has to have 4 sides and
4 corners.
yeah.
Oh.
We had some quadrilaterals in our sort. We sorted things that did have 4 sides and 4 corners. Were there any other rules? Think about what we had a rule for in our triangle. Are there any other rules? Archer?
It has to be closed.
Has to be a closed shape. We can't have holes in it. Just like our triangle, we can't have holes. Has to be a closed shape. Any other rules? Marley?
It has to be straight side.
Has to be straight sides. Just like our triangles, could we have special quadrilaterals that have extra rules? Yeah. We had one earlier. Remember we made a quadrilateral that had equal side sides? That's an extra rule. Quadrilateral doesn't have to have that, but it could.
You mean you read that?
We are writing what I'm writing. quadrilaterals. This is the tricky part.
Oh,
Learning to do
yeah.
it in third grade. Have more than one name. Save it. I know what you're gonna say. Save it. Give it some time to think about this. Many quadrilaterals have more than one name. I like to think of this as like a nickname. Right? Many of you might have a nickname that you go by.
Future.
You might have more than one name.
Oh, that's my nickname.
I didn't ask for that announcement.
Dog.
So let's look at this shape. Yeah, so I just said look at that shape. Just draw that shape.
Is that a square?
We know, based on our rules, let's look at my rules. 4 sides, 4 corners. Does it have 4 sides, 4 corners? Yeah. Does it have, oops, went too far. Is it closed? Are there any holes? No. Does it have straight sides?
Yes.
So what can I call that shape?
Straight.
Yeah, this is called a quadrilateral. However, some of you probably also know this shape by its other name. How else would you say this shape? It's got another name. Raise your hand to tell me. Alright, turn around. Julian, what else would we call that shape?
Square.
Yeah. Now, none of these names is a better name, which means it's more specific. If
Another name.
some of these shapes have a best name. If I say quadrilateral, think about all the quadrilaterals we looked at today. That could be so many. So this shape's best name is square. It's the most specific name. Put your scissors up, Martha. Alright, so let's look at another shape that you probably recognize.
Oh, that's the right thing.
Look at our rules. Does it have 4 sides, 4 corners?
Yes.
Is it closed?
Yes.
Does it have straight sides?
Yes.
What can I call it?
Quadrilateral.
It is a quadrilateral. That is a correct name for this shape. Is it the most specific name?
No.
No, you probably know it by a better name.
Rectangle.
Raise your hand to tell me what is the better name that you know this shape as. Mason? Rectangle. Now, does that mean calling it a quadrilateral is wrong? No, it's just not as specific. It's not the best name. Just like you have a specific name. I could say, hey boy. If I'm talking to Colby, is that wrong?
No.
I could say, hey third grader. If I'm talking to Addison, is that wrong?
No.
No. If I say, hey Paxton, do you know specifically who I'm talking to?
Yeah.
Yeah, it's a more specific name.
I mean, this Freddie Paxton.
Please stop talking over me. It's the more specific name. But calling Paxton boy and third grader, they're not wrong. They're just not as specific. Shapes work the same way. Depending, all right, no thank you. Depending on the shape, it might have more than one name, but one of them might be better than the other. Jordan, thank you for raising your hand.